Hello everyone, today I'm going to deliver a lecture on slope stability. So let's start. Here is a we can see a footing is excavated soil from this footing, and we can see the lateral force, which is F of x, and vertical force is F of y, and the resultant is coming from in this direction. And another, we can see another picture which is slope 1:2, which is vertical is 1 and horizontal is 2. Is the hilly area. We can see here the weight of the soil is coming through the center of mass, and here is a road also, and there is a building example we can see. Here is we can see the induced moment equal to resisting moment must be equal to 0. The induced moment equal to ws is nothing but is weight. So weight equal to p equal to unit weight of specific unit weight of soil, as we are doing the soil slope stability of soil. X bar is x is a center of the CG of the specific point, which is 0.424 r, or we can see 4 by 3 4 r divided by 3 pi, 4 r divided by 3 pi. We can see another is resisting moment, which is A is the surrounded area, and C is the shear strength, and R is the radius. And now we have to focus on factor of safety, which is strength divided by induced strength, which is resisting strength divided by induced strength. Okay, so let's see the example. Here is an example. We can see that determine the factor of safety against stability of the natural or original slope of the hilly for the following cases is given value. You can see here the hilly area, the slope is given here, and the radius of the slope is 10, and you can see the weight is passing through the center of gravity of CG. So induced moment, we know mi, and induced moment weight equal to volume into unit weight of soil and x bar. So we are pushing the volume pi d square by 4 into 1. Pi is 1. We are taking the 1 feet of the unit weight, and unit weight of soil is 120, and x bar is 0.424 r, or 4 r by 3 pi. So r is 10 is given here. So in this way we have found 4000 pound per feet, which is 40 kg per feet. So M60 is given 20, which is coming from the SPT value M60, and C is we know the C is Q divided by 2, and this is the formula we have been found from various code, which is 300 divided by M60 divided by 2, and C equal to 300 psi. And similarly we can calculate the resisting moment, which is perimeter of the slope, and cohesion and radius. Cohesion C, and R is radius, we know C is so perimeter of slope equal to 2 pi r, as we know that this is the perimeter 2 pi r, r is 10. So 2 pi r, this is the quarter circle, so that's why we are divided by 4, and putting the value C as is given the PSF, we are taking into the KSF, that's why multiplied by 1000, and R is 10, and found for 17.24 cubic feet. So factor of safety will be resisting moment divided by induced moment. Resisting moment is found here, and induced moment is 40. So this is 11.74, which is the greater than 1. So this is the safe. If the factor of safety is less than 1, then you will say that this is unstable or unsafe. So determine the factor of safety, and there is another example. Against stability, the original slope of the hilly rock clay soil and the following cases is shown below. So R is given here, the same. X equal to, we know, the 0.424 R, and ND equal to 80 PSF, and N60 is 12 of psi equal to C. So we know the unit weight of soil is given 80 KSF, R equal to 10, and N60 to 12, and C equal to Q by 2, which is 360 by 2. But we can say 150 into N60 as we demolish divided by 2 both sides, and found 1.8 KSF. So induced moment equal to Yt into x bar. Yt equal to we know the volume into unit weight of dry unit weight of soil. So and the CG is from here is 0.424 R, and volume we know W pi by d square by 4, pi d square by 4. So 4 is here, as we seen, this is the quarter circle, and 1 is a 1 strip, and gamma d is given here, and in this way we have found 26.6. And resisting moment, we know perimeter of as we have seen perimeter of slope zone. So perimeter of slope zone is 2 pi r. This is the main formula, 2 pi r, and we will divide it by 4 because this is the quarter circle, and one is a strip, and C is we already known here. C 360 divided by 4, which is 1.8, and 1.8, and R equal to 10. So in this way we have found 282.6, and putting this, and found the factor of safety is 10.6. So this is safe and stable. And another one, we can see the determine the factor of safety against stability and natural or original slope of the hilly clay soil for the following cases is given. So case is given here, so you can see the R equal to 10 feet, and soil is given. X bar we know 0.424 R, and the saturated unit weight of soil is 130 is given. 130 is given. R is 10 feet, and N60 is 1 is given from, it is coming from SPT below, and C equal to Q divided by 2, which is 360 divided by 2, or we can say 150 into N60. So this is the 0.150 KSF, and in this way we are calculating induced moment, which is weight into x bar. Weight is nothing but volume into unit weight of saturated soil, and found, putting all this below, and found 43.49. And resisting moment, we know the perimeter of soil, perimeter of slope zone, and C is given. C is found 0.150, and R equal to 10, and perimeter of soil 0.2 pi R divided by 4, and putting this value, and found 23.56. So and all this value putting all this value in resisting moment divided by induced moment, which is found 0.54, which is less than 1. So less than 1 is not stable, and soil will be full. So what is the precaution we will take if soil is unstable? So this is a theoretical question. What are the solution for unstable soil or failure? So one is the we have to put the, this is our slope zone. So we have to load the concrete blocks. This is the one. Another one, we can induce the soil nail pile, which is we can insert a pile into the soil, and we can another precaution take, which is that we can what I will say, we can produce, and we can tree plantation. We can I don't know how can I explain, that we can induce the grasses. That's why if you induce the grass and trees, then our C and N60 will be increases. In this way we can induce the soil strength. So here is another example. You can see that determine the factor of safety against the stability and the natural original slope of the hilly clay soil, and the following cases is shown below. uh, as we can see here, the slope is very complex. That's why we are dividing 1 2 3 portions. Okay, so let's see. Here the moist soil is given. The unit weight of moist soil is 100 psf and R is 10 feet. And 60 is found from SPT value, which is 8, and C equal to, we know, 300 R and 60 divided by 2. So in this way 1.2 ksf. Okay, let's start. The area of soil in the total area minus hollow area. So we can see here is a total area is here. Pi d square, which is 10 divided by 4, as this is the quarter circle, and this is the zone 2, which is pi half. This is, we can use the triangular formula as we are dividing this region. We can say half into length into height. Into length is 10 and height is 3, and another we can divide another portion separate here. This portion is a3, half into length is 10 and height also 3. So in this way we can calculating the area of soil. So this is the area of soil, 48.5 friend. The area of soil of CG into CG. So area of total area into CG of total area, and hollow area into CG of hollow area. So we can put the all value, a1 x1, x1 prime is ungiven, and a into x prime minus a2 x2 minus a3 x3. Okay, so we can putting all these value, a1 x1 is unknown, and a is total area. We can here putting all the total area we have calculated previously. Okay, so another is CG of the a1 is 0.424 r is given here, and a2 in the same way. A2 we can calculate here, area of a2. This portion is a2, and half into length into height, and CG is 1/3 of height. So 1/3 we are taking from this apex point. That's why we are using 1/3, and height is 3. And the third portion we have been seen here, the area half into length into height, which is half into 10 into 3. But the problem is the taking the CG. So we can find out the another CG individually. This portion we can say here. This portion we are taking here. So this is 3 and this is 7. As we can see, the apex height is 3, and the apex point to this point is distance is 3, and rest of the point is 7. So we can if we sum this point, sum this length, then we will found the 10. Okay, so we know the basic formula. This formula we have used, area of soil into CG equal to total area minus hollow area. So we can use total area in area 1 into area 2. So total area we know half into length into height into x bar, and a1, this is the a1 we are denoting az. Half into length is 3 and the height is also 3, and this portion is z. We can see half into height. We can sorry, this is the what I will say, this is the x bar, which is CG of this portion, only y portion, 2/3 into 3 there, because we are calculating from apex point. That's why we use 2/3 into h. Okay, so the jet portion is here. This is the jet portion, and the area of jet portion half into length. Length is height, length is 7 and height is 3. So this is the height, and this is the what I will say, this is the CG, or this is the CG of the jet portion. We are adding 3. This is 3, and from 1/3 of length, 1/3 into length, and found 4.33. This is the 4.33. And x bar we have found 4.8 from jet. So this is the x bar from jet. We have found for 5.83. So in this movement, wx into x bar, also b into volume into unit of soil, and x bar, and volume we know 48.58. One is steep, and 100 is unit weight, and found 48.89. And resisting moment we know perimeter zone, which is 2 pi r divided by 4, and c is we have found 310 into 2. We are dividing 100 because we are taking the pound to keep, and r is 10, and found 188.5. So resisting moment divided by induced moment, which is greater than 6.6, so this is the stable. So another example we can see here, determine the factor of safety against stability and natural original slope of the hilly road clay soil. For the following cases is given below. Here you can see here the moist soil is given also 100, and r is 10, and the SPT value is 8 also found, and c is n 300 into n60, which is 8, and divided by 2, which is 1.22. And the same area, total area, area of A1. So this is A1, the soil area, the total area minus hollow area, the total area pi d squared, pi r square, which is 10 divided by 4, and hollow area half into length into height, which is 10 to 10, and found 28.2. And the same area of soil into CG of soil, which is total area minus CG of area and hollow area. We are in the same way we have calculated 5.83. The induced moment equal to W is into x bar. W is nothing but volume into unit weight of soil. So volume is 28.8. We have found 28.54, and 1 into x bar 5.83, and found 16.6. And resisting moment, a moment a bar, the white sloping zone, and CR. So we have found 188, and the factor of safety is resisting moment divided by induced moment, which is 11.3, which is greater than 1. So this soil is stable. So let's see another example. This is the big example, and we have to we have to draw the attention here. So determine the factor of safety against of the natural origin slope of the hilly rock, and the following cases is given below. So case is given the natural soil. This is the segment 1 to 3. So segment 1 to 3, and areas also there are 383, and arm is also 380.2 is given here. So there are 2 layers. We can see the sand, clay, and sand, K average SPT and 5, and unit weight 110, and layer 2 is clay, and SPT value, average SPT value count is 10, and unit weight is 115. So we can see here the total segment is 6, 1, 2, 3, 4, 5, 6, and layer 1 is here. This portion is layer 1, and layer 2 is here. So we can see segment 1 to 6, and volume segment 1. This is the 1, and half into length 6.3, and height into 10, and found 37.8, and unit weight is given 110 is here given. And weight, how we'll get the weight? Weight is nothing but volume into unit weight. Volume is 37.8, and multiply with 110, and divided by 100, 1000, because we are taking the pound to keep, and found 4.1 on 158. And arm is nothing but 38.6 is 38.2, 38.4, 30.3, 40, and 6. This is the given. If we arm is not given, then we can calculate the arm. So arm, if we how we'll get the induced moment, the quiet into arm. So if we multiply 4.1.8 into 38.5, then found 159.25. So I want to see the how we'll calculate the arm. So this is the calculation of detailed calculation of arm. So you can see here, here you can see the 42.39. So this at the given 43.49, r is given for 45. 45. So this is the 31 and 39. So total is 70.4. Here is a given 31.9 and 49. And we can use the sin theta length into hypotenuse, and sin theta 70 into height into hypotenuse. So height is 42.49. So 42.39. And arm, how we'll get the arm? Arm is nothing but there is the arm is the length of between a specific point to the CG. So x1, this is the x1. I will get 42.39. So this is the 42. The total length we have found 42, 42.39, and minus 2/3 because we are coming here 2/3 into 63. 63 is given here. So this is the 38.3. Another one, this is the 2. So 42.39. Total length is 42.29, and deduct the 6.3 at first 6.3, and then this portion will coming here, which is 3 1/3 into h, and found 33.5. In this way x3, x4, x6 is found, and in this way we will calculate the arm. Okay, so let's here. So induced moment, we are if we calculate here all the induced moment, we will found 336.19. This is the induced moment. Okay, so resisting moment, there is a two type of layer we can see here, layer 1 and layer 2. That's why we are dividing into M1 and M2, SCR1 and SCR2, and we are calculating here C1 and C2 equal to 2 pi r 360 divided by theta, and C1 equal to q by divided by 2, or 360 divided by 2. And we have found C1 equal to 0.75, and in this way we can calculate C2, and average speed is given 10. That's why we will find 1.5, and putting this value, C1 0.75 and C2 is 1.5, R is 45 is given, all the direction, S1 and S2, and 2 pi, and R equal to 45. We know the 45, 360, and theta is 38.2, 31.2. How this is 31.2? We know the 31.4. 31.4, and another one, theta is 39 into 39. So this is 39 and 39. This portion and this portion, there is a two, will divide it into two segments, and found 4967.2, and factor of safety in resisting moment divided by induced moment, and found 3.7, which is greater than 1. So this is the safe. The slope is safe. So let's see another example for here. You can see the for the infill slope is shown here below. They assume that there is a groundwater seepage and groundwater coincide with the ground surface. Determine the factor of safety and height of the height of when PS is 1. Okay, you can see factor of safety here, C divided by gamma situated h into cos beta square, and tan beta plus gamma prime gamma situated tan phi by tan beta. So all the height is 6 is given, beta is 15, saturated is 18 kilonewton per cubic meter, C is 10 kilonewton per meter square, which is 10 kPa, and phi equal to 25 kPa, and found factor of safety 1.16, which is greater than 1. Okay, so this is okay. Another one is factor of safety is given 1, so we have to calculate the height. So factor of safety is we are putting here, and the height is unknown, and found height is 10.56. Estimate the factor of safety for slope having h height is 20 milli, and d and beta is 25, and s 19 kilonewton per meter square, and cu is 15 given here. Factor of safety, we are putting all these value as the value of phi is not given, that's why this portion will be kilo or kilo. So factor of safety is 1, so this less than 1, we can say this is unstable, so this is not appropriate. So another one we can see here is a cart to be the made of the soil in that has gamma equal to 16 kilonewton per cubic meter, C equal to 28 kilonewton per meter square, and phi equal to 20. The slide of the cart slope will be make the angle 45 with the horizontal. What should be the depth of the cart of the sloping? Will be have the factor of safety is given 15. So we know the factor of safety C divided by CD, and putting all the values, and found CD equal to 8 kilonewton per meter square. And another formula we have been found here, the factor of safety equal to 10 phi by 10 phi d, and putting value of the factor of safety 3.6, and found phi d equal to 5.9. And in this way we know the depth of cutting here, h equal to 4 into CD divided by gamma equal to sin beta cos phi d, 1 minus cos beta minus phi d, and found 6.28 meter. So okay, so this lecture is in depth. If you have any question, then ask me or comments here. I will try to answer. Thank you everyone. Thank you.